Hello everyone, hope all of you are fine and safe. Today we are going to learn couple, turning effect of forces. Let's move towards the... Okay, here we are going to explanation of the couple. In this picture you can see a ball. You can see there are two forces but in an opposite direction. The first one force is due to air or resistance, and the second one force is the force of gravity, which is very common. So it means a ball having a two types of forces but opposite in direction. It means the couple in the mechanics, pair of equal parallel forces, equal but parallel forces that are opposite in direction. The only effect of a couple is to produce or prevent the turning of a body. The turning effect of a movement couple is measured by the product of the magnitude and force. So the moment of a couple is the product of the magnitude of one of the forces and the perpendicular distance between their lines of action. Means M is equal to Fa and xd. It has the units of kept feet, pounds and inches or Newton meter. The magnitude of a moment of a couple is the same for all points in a plane or a couple. A couple may be removed anywhere in a plane or a parallel without changing the external force. The external force means your force, so the magnitude of a couple is independent for the reference point and its tendency to create a rotation will remain constant. This can be, you can say that a simple bar with a length d that is pinned at a midpoint. So the two parallel forces of equal magnitude opposite in sense and applied at the end of a bar. So the magnitude of a moment generated by the couple of forces F relative to the pin and it's equal to the whole body or the action. You can say that F, this is the basic formula, that F and D. The magnitude of a couple of the forces F relative to the point O is F and after that D plus X. And when you arrange the formula in this type, then we get F and D. Again, it can be seen that the magnitude of a couple is dependent of the reference location. It is always equal to F and D. So there is a common example of a street lamp. The lamp creates a moment with a magnitude determined by the weight of a lamp time the moment arm D. This moment is resisted by a couple generated by the tubes of a supporting arm. The two forces of the couple can be seen in this type of tension or forces that are maybe much smaller distance. These act to put the system back into the equilibrium position. It's too much important for the lamp because they are applying two forces at a time, the force of air and the force of gravity. In this situation, it's so much important that how it's hang, and while hanging what will be the position, and if the two forces are working collectively or acting on the same object, so as a result what we get. There is a common example, another example, the wheel of automobiles turning by a hand forces, and there is a chain of your cycle. So you can see that when you are applying a force, then as a result what will produce? You can move from one place to another place or moving object. So in the addition to the turning moment, it creates an unbalanced force on the element being tangent. So let's move towards the second topic, which is center of a mass. The center of a mass, what it is, basically in this picture you can see a body or a human body that if he is standing in a straight form, then this center of a mass is totally changed. After that, when he is hands up, so the center of a mass is changed. After that, in the last moment, you can see the mass is totally center of a mass or the center of gravity is totally changed. So the center of a mass is a position defined relative to an object or system of object. It is average position of all the parts of the system. For example, uniform density and center of a mass is located at this point. Okay. In the term of center of mass and center of gravity are used with each other in uniform gravity field to represent the unique point in an object or a system which can be used to describe the system type. That's the reason the couple of a center of a mass is that of an average of a masses by the distance from a reference point in one plane, that is like it balancing of a seesaw. So about in this picture you can see the center of a mass. This is a seesaw, maybe in somehow you can say this is a seesaw. Mass 1 is mass 2 is much heavier than mass 1. So as a result, when both of them are on a seesaw, what we get for two masses, we have m1 x1 plus m2 and x2 means mass 2. So mass 1 plus mass 2. Will you please tell me that how can you say that this seesaw is balanced? So the answer of the question is that you can see maximum, if you have a ruler in your hand and just pause the video and just you can see that mass 1 distance between the midpoint or the center point is too much or totally change from the distance of a mass 2. It means the distance is always affected. That's why the center of mass or the center of a body will also affected. So how we are going to find out the center of a mass of an object? There in this picture you can see a duck. It is a irregular picture. Okay, if the picture is a square or a round, then it is too much easily we are easily find out the center point or the midpoint of the object. But in this shape, it is a irregular shape. How we are going to find out the center of the mass? It is a very interesting experiment. In this experiment, you just hang a duck or a irregular shape in this way that you can see, and with the thread you measure all the area, and after that from the 4 different points you can measure all the area, and after that you are just near to the midpoint or the center of the mass or object. So let's move towards the equilibrium. You know very well what is equilibrium. Equilibrium is the position in which the body is stable. The body is stable, and in this seesaw you can see that there are two little babies, and both of them are sitting on a seesaw in a very balanced way. This position is called equilibrium position. Why this position is called equilibrium position? Because it is a stable position. There is no fear for falling down or something else. Let's move towards the topic that what we are going to learn in the equilibrium state or equilibrium position. So in our physics, equilibrium condition of a system when neither its state or motion internal energy state tends to change with time. For a single particle, equilibrium arises if the vector sum of all forces acting upon on a particle as a zero. In this picture you can see the balance of person with a 1 foot. So it's too much interesting. Let's move that what's the next explanation about this. There are some rules for the equilibrium, a condition in which all the influence acting cancel each other so that a static or a balanced situation results. In physics, equilibrium result from the when you can see the picture is too much funny that on a seesaw, if one side is a heavier one person or a heavier body or a heavier object, on the other side a lighter weight person or a lighter weight body, so it's the condition will be just like that, which is in front of you. So there are some rules for that, and the rule is that how we are going to balance them. Maybe the distance will increase or decrease, or maybe the object will moving with another criteria, or maybe the center will be changed. These are the 3 or 4 conditions which is the basic equilibrium rules. So the forces are considered to be balanced if the rightward forces are balanced by the leftward forces and the upward forces are balanced by the downward forces. This, however, does not necessarily mean that all forces are equal to each other. Consider the two objects which is just in front of you in a picture. So note that the two objects are at equilibrium because the forces that act upon them are balanced. However, the individual forces are not equal to each other. The 50 Newton force is not equal to the 30 Newton force. But how it's possible that both of them are equally arranged? It is just possible when we are going to change the position of the 50 Newton and we increase the distance between the 30 Newton weight and 50 Newton weight. It is a simple and common way from which we get equilibrium state or equilibrium position.